Assalamualaikum warahmatullahi wabarakatuh, and hi doctor and everyone. My name is Hannan HAMIZAH binti Zuri. Today I will present about study and evaluation of carbon sequestration using remote sensing and GIS. For the introduction, carbon is found in all living organisms and this is major building block for life on Earth. Carbon exists in many forms, as a plant biomass, soil organic matter, and as the gas carbon dioxide in the atmosphere and dissolved in seawater. Carbon emission through different sources, and carbon is a causal factor for global warming, which is the most problem across the world. Carbon dioxide concentration drop, Earth will cool, some water vapor falls out of the atmosphere. When carbon dioxide concentration rise, air temperatures go up and the more water vapor evaporates into the atmosphere, which is then implies greenhouse heating. Atmospheric concentration of carbon dioxide have been steadily rising from 315 parts per million in 1959 to a current atmospheric average of 385 part per million. Next is ways that carbon can be stored. First, in plant and soil, terrestrial sequestration or carbon sinks. Second, underground, geological sequestration. And third, deep in ocean sequestration. The table shows a technique for above ground biomass estimation. There is three categories. The first one is field measurement based method. The field measurement based method have three methods that we use. The first is destructive sampling and the second is allometric equation. Both of these methods use the same data and characteristic. The data used is sample trees and the characteristic is individual trees. The second one is conversion from volume to biomass. The data that we use is volume from sample trees or stand, and the characteristic is individual trees or vegetation stand. The second category is remote sensing based method. The first method is based on fine spatial resolution data. We use aerial photograph and iconos data. The second one is method based on medium spatial resolution data, and the data we use is Landsat and Spot. The third one is method based on coarse spatial resolution data, and the data that we use is IRS, R1C, WIFS, AVHRR, and the last one is method based on radar data. We use radar and LiDAR. All of for this method, we use the same characteristic, which is per pixel level. And the last category is GIS based method. Method that we use is based on ancillary data, and data that we use is elevation, slope, soil, and precipitation. And the characteristic that we use is per pixel level or per field level. Remote sensing data has become an important tool for the estimation of forest biomass. Biomass estimation using remotely sensed data is emerging technology and it is being increasingly used to inventory forest biomass. Satellite-based estimate of carbon stock are likely to become more accessible over the next few years. So I will explain about the biomass estimation using Landsat TM data. The first data set is Landsat 5, and the technique is linear and exponential regression. Multiple regression analysis estimate crown diameter using an exponent model, then calculated biomass using crown diameter, k-nearest neighbor method, and multiple regression analysis. The second is Landsat 4 and 5. The technique that we use is multiple regression model and neural network. The third data set is Landsat 7. We use multiple regression analysis technique. And the last one is Landsat TM derived land cover data, forest inventory data, and climate and soil data. The technique that we use is a productivity model, BNET. For the conclusion, we can conclude that carbon dioxide is one of the most common greenhouse gases resulting global warming, which in turn brings about rise in sea level, drought, deforestation, and others. Forests, soil, ocean, and atmosphere are agents for storage of carbon. Carbon sequestration describes long-term storage of carbon dioxide or other forms of carbon to either mitigate or defer global warming and avoid dangerous climate change. It has been proposed as a way to slow the atmospheric and marine accumulation of greenhouse gases, which is released by burning fossil fuels. The remote sensing and GIS technique like image classification technique, vegetation index model, and estimation of above ground biomass method are used for estimating the carbon sequestration. Land use and land cover mapping was used for comparison and estimation of carbon sequestration, either increase or decrease. Spectrally based normalized difference vegetation index (NDVI) and other vegetation indices derived from remote sensing platforms are common indicators used to monitor biophysical condition and vegetation cover. These indices are solely designed to optimize the spectral signatures of vegetation and minimize the influence of soil reflectance and atmospheric attenuation. GIS data layers and NDVI measure were manipulated to estimate carbon dioxide sequestration in a particular area. The combined use of biomass model and NDVI data has simplified estimation of carbon stock in forest area. Agricultural land is available in great quantities as natural resource. However, the potential of this land as carbon sinks during the cropping season has not been speculated or exploited to the optimum. It is high time that the world and the example is India in a particular understand that there are alternative sinks of carbon apart from the traditional concept of forests being a sink. Forests are major source and sinks of carbon in nature. Estimation of forest carbon stock enable the access of amount of carbon lost during deforestation or the amount of carbon that a forest can store when such forests are regenerated. The principal element for the estimation of forest carbon stock is the estimation of forest biomass. Okay, so that's all from me. Thank you.